to troubleshoot a network here, and these are top 10 enterprise network troubleshooting scenarios that every network engineer must know. This is a guide that I have created to help me teach you how to troubleshoot an enterprise network. An enterprise network is only useful if it's reliable and available. So for a network engineer to be able to troubleshoot enterprise network, he or she should master these 10 enterprise network troubleshooting scenarios. So I'm going to use Cisco Packet Tracer to effect this particular objective, so that this guide combines real enterprise troubleshooting scenarios with Cisco iOS commands, Packet Tracer simulation tips, and core engineering skills required to diagnose and resolve the network issues efficiently. So these are the issues that I'm going to talk about. Issue number 1, no connectivity, either layer 1, layer 2, or layer 3. So you may find that in an enterprise network, there is no connectivity. When there is no connectivity, these are the things you should check. First of all, test the cables. Check if the computer is connected to a cable, if there is loose connection, or the cable is faulty or not working. 2, check the interface status. So we will check the interface status using these commands: show IP interface, show IP interfaces, and show IP interfaces brief. So using simple PDU tool, you can check the links, lights. So step by step, I'm going to show you these particular scenarios in Cisco Packet Tracer. There is a network that I have configured and cabled and configured it already to help me use as a use case for this particular troubleshooting. Scenario number 2, the DHCP failure. When this happens, you may find a scenario that a computer is not able to connect to the network. First of all, check if it has the valid IP address within the dedicated subnet. Check if at all DHCP has been successful or it has received IP address automatic. If not, it might have an IP address like 169.254.00. If a computer on a network finds itself having such an IP address, that's an APIPA address which cannot communicate on the network. So first of all, on DHCP failure, check if the DHCP pool is well designed, or the DHCP relay address or the IP helper address is configured well. After that, check whether the DHCP server is on or off, or is the DHCP server having the right subnet that your nodes should have, and also verify the client. So there are commands to check that. Debug IP DHCP server events, then you'll notice the DHCP statistics that are there. There is IP DHCP statistics, then IP DHCP binding. So all those the troubleshooting commands will help you to know the status of DHCP. So that is scenario 2. Scenario 3, the DNS resolution issues. You may find that you are unable, a user in an enterprise network is unable to access the domain name service. So for that to be troubleshooted, you use what we call nslookup, whereby you are going to look up between the IP and the IP address of the web server or the domain server and the domain name. You are going to show hosts on the Packet Tracer. This is possible. Also check the status of the server. The server might have not been configured or configured wrongly, test the domain name, test or check the right name that is bound on the particular IP address, check the default gateway, also check the right the subnet mask, because subnet mask is used to identify the network. Also test the name resolution. So these are the tests that you can at least carry on DHCP issues. So these are the top 10 troubleshooting scenarios that I'm discussing with you, just to make you aware how to provide this timely support on the network. Scenario number 4 is a VLAN misconfiguration. So the skill that you should have to handle or to be able to handle this particular scenario is that you should be proficient in VLAN segmentation, know how to create VLAN, assign interfaces to that particular VLAN, describe that particular VLAN. So by doing so, it elevates the issues that can occur around the VLANs. Also trunking. Trunking is a technique whereby a trunk port is used to move traffic from multiple VLANs, or a trunk port is used to allow communications to occur among multiple VLANs, so that for VLAN A to communicate with the VLAN B, VLAN A has to send the traffic to the switch, to the router, so that the router can decide where to resend this particular traffic. So, and that is only possible through trunk port. So you should be able to know, how to configure trunk port, because without trunk port, Inter-VLAN will not work. So, and that one might bring down your network. Also, in real enterprise network environment, you might find that VLANs are commonly used, and this is used to segment the network. Right now, in normal environment, departments, we call it departments, but from the network standpoint, this is VLANs. So, for example, department like hospital or security is in respective VLAN, in specific VLAN. Administration is on another VLAN. Maybe warehouse is on another VLAN. So you see, this warehouse, office, and the other department should communicate. For such to happen, a layer 3 device should be into the mix, and that should be a layer 3 switch. Layer 3 switch has the routing capabilities, and or a router. So the two should be either one of them to effect multi-communication in Inter-VLAN setup. So VLAN misconfiguration is an area that you will not miss an issue arising. To verify that, show VLAN brief. So this one will show the VLANs that are configured on the switch. Show interfaces trunk. So it will show which interfaces are in trunk mode, sorry. So switch VLAN config plus trunk links. So on the switch, you should understand this. Inter-VLAN routing failure. So what are Inter-VLAN routing failure? You might find that VLAN 10 is not communicating with the VLAN 20 is not communicating with the VLAN 30. So what might be the reason for this? You might find that the sub interfaces are wrongly configured, or the IP address that would be bound, that have to be bound on the sub interface, is not well configured. So those are the checks that you should understand, and also ensure that the 802.1q protocol is enabled. If it's not enabled, multi-VLAN communication is not going to happen. So to achieve that, especially in the VLAN routing, layer 3 switching can happen on using a layer 3 switch or router on stick, whereby we use one router and then hooked on a switch supporting multiple departments. So commands to use that, you can use show IP route to show the routes that are there, show running config, it will show you all the configuration that are configured there, or show interfaces, it will show you how sub interfaces are configured. So scenario number 6, high latency or congestion. A user calls you to report that he's having low connectivity or the network is so slow. So what might be the reason behind that, or what are the skills that you should have so that to solve that particular issue? So you should be proficient in traffic analysis. There are tools on the internet or a network that are used to analyze traffic. For example, we've got Wireshark, we've got TCP dump. So Wireshark is used to capture packets. You can capture the packets and understand which packets are taking preference over the other, which sites are being accessed, which subnet it is in use. You see? Second, QoS basic commands. So quality of service. So you find that on a converged network, I mean where data and voice is combined. So in that scenario, voice is given preference over data. So this user might exist in a department supporting voice or supporting data, and voice kicks in. He will have issues over that, because voice media related information always is just bandwidth hungry. It takes preference over data. So to verify that, you should check whether the user is in the right department, because quality of service, the priority is different when it comes to the two. So these are the commands that you're gonna use. First of all, you will ping the gateway. If the gateway is reachable, you will ping Google. If the user is able to reach the Google, that is ping 8.8.8.8 or ping www.google.com. Tracer. This is used to trace the route. It will show you the hops that it goes through before it reaches the gateway or the internet. Show processes CPU. So this one will help you to understand which service is consuming more resources than the other. So in Cisco Packet Tracer, we can simulate this using a simple PDU, protocol data unit. So these are the skills. I'm going to check each one of them. Packet loss. The packets are being lost. What might be the issue, or which skill you should be having to solve this? Physical troubleshooting. Check if the device is well connected, the cables, there is no loose connection on the cable or on the around the cable. Also check the duplex mismatch, because you find that we've got the auto negotiation whereby there is that automatic negotiation when the sender and the receiver can communicate either in the same speed or in the same duplex mode. So check if one side is a half duplex and the other is full duplex, there will be packet loss, because the receiver cannot stand to receive the packets being sent by the sender. So there is duplex mismatch. The commands to check that is show interfaces. You can see show counter errors, so that in this you realize there are runs and giants. So runs are these packets that do not meet the minimum requirement of a packet in a network, and a giant is a packet that supersedes or exceeds the set standard of a normal packet. So if giants are more, then there is an issue. Then the runs are more, there is an issue. So this should balance. As a network engineer, you should understand that, and you should understand how to reach and troubleshoot that. So also inspect the link lights. When it is in amber, it is negotiating. When it is green, it is steady. Cable types also. For example, we've got cable categories. We've got Cat 5, Cat 4, Cat 6, Cat 5e. Those categories, they have different bandwidth. So mismatch of such might lead to a packet loss. Also the crimping, the way crimping was done. Crimping is just the process of attaching RJ connectors on the UTP cables using a crimping tool. So this is a core skill or a core scenario that you cannot miss in the network. Number 8, firewall ACL blocking. So firewall or access control lists blocking traffic. So ACL, access control lists, are designed for security policy analysis. So to achieve that, as a network engineer, you should be well versed with the scripts. You should be well versed with the scripts